As I have discussed in previous chapters, C++ provides numeric data types, such as short integer, long integer, and float, for storing numbers, and a character data type for storing one character only. However, unlike many other languages, C does not provide a built-in string data type for storing more than one character of data. In other words, for storing data such as a person's name or an address. Although the string data type is not built into the C language, you can indeed implement it using the C's character data type. You will note that the syntax for declaring a string variable is almost identical to the syntax for declaring a character variable. Recall that you create and initialize a character variable by using the char statement. Similarly, you create and initialize a string variable by using the char statement also. The difference is you use square brackets to indicate the size of the variable. The number inside of the square brackets is a number that is one more than the maximum number of characters you want to store in the variable. For example, to store 11 characters in a string variable, the value in the brackets must be 12, which will store the 11 characters plus the null character that C automatically adds to the end of a string. The number in brackets actually tells C how many 1-byte memory locations to save for each use of the string variable, plus the null character. Unlike character variables, however, which you typically initialize to one space enclosed in single quotes, string variables are usually initialized to a zero-length string. A zero-length string is simply a set of double quotes with no space in between, such as you're seeing now. I'll compile this program to see the effect. As you can see, it compiles without a problem, and we now execute. If I type in a person's name, such as John, and press the Enter key, you'll see that the program responds as you might expect. What the program is simply doing is accepting data from the keyboard after a prompt and then displaying the result with a cout statement. The data can accept more than one character since we have declared that number inside the brackets. In essence, we've created a string variable by using the character data type. Now let's run the program one more time. And this time I will type in the person's name along with their last name, leaving a space in between the first and last name. As you can see, the value of the variable is simply John, not John space Smith. The reason for this is that a string data type, which is actually a multiple of character data types, will not accept a blank space. As soon as this space was entered, the data was terminated and no more characters were accepted by the keyboard. You will recall that the cin extraction operator stops reading characters from the keyboard as soon as either the user presses the enter key or types a character that is inappropriate for the variable's data type. In the case of string variables, an inappropriate character is the space. Another important note, if the user enters more characters than the string variable can store, C stores the additional characters in memory locations adjacent to, but not reserved for, this variable. Storing additional characters in these unreserved locations may write over some important information in memory, perhaps even crashing your system. Since it is common for string constants to contain one or more spaces, the next section will show you a different way to enter data into a string variable, a way which will allow the data to contain spaces. You can use one of the cin string's member functions called getLine to enter data that contains spaces into a string variable. This will be discussed in the next segment. In the previous demonstration, it was demonstrated that a string variable is incapable of accepting a space as a character. There is a special part of the cin class that allows you to create code that will permit a space to be entered as part of the data. The cin statement is an object that belongs to a class named iStream, which is defined and made available in the iostream.h header file. Included in the definition of the iStream class are functions referred to as member functions. Because they are members or parts of the class, one of the iStream member functions is called getLine. The syntax for using the getLine member function is the object.getLine and then the variable name followed by the length of the string. I will modify the cn statement to allow the cn getLine function to work. The syntax is cn.getLine parentheses the name of the variable, which in our case is client name, followed by a comma, and then the number of characters that you want to accept. Remember to include space for the null terminator. And then parentheses closed. The remaining of the original statement can now be deleted. The statement still ends with a semicolon. Now we'll recompile our program to see if it actually works. After a clean compile, the execution of the program will run as before, but this time when I type in a person's name with a space in between the first and last name and press enter, you'll notice that the client's name, in this case John space Smith, is accepted into the variable, where in the previous demonstration anything after the space was ignored. So the cn getLine is the statement that you want to use when you want to allow the user to accept characters which include spaces. There is one more limitation to the string variable in C that you need to be aware of. Unlike other variables in C, a string variable cannot be assigned a new value from an assignment statement. Rather, you need to use a special function called the string copy to assign a new value to a string variable. To use the string copy function, you must include the string.h header file in your program. You will want to include this header file immediately below the IOStream header file. This compiler directive now makes a variety of functions available to the program, including the string copy function. To demonstrate the use of the string copy function, I will delete the cout and cn getLine statements and replace these statements with the following line of code. strcpy, which is pronounced string copy, left parentheses, and then the name of the variable, in this case client name, comma, and then the name that you want to assign to this variable, such as John Smith. Parentheses closed, semicolon. This statement will now store the name John Smith into the variable client name, rather than having the user enter it in. Note the string copy function is used as an assignment statement, just like an equal symbol might with a numeric variable. Let's run this program to verify the results. As you can see, the client's name has been stored as John Smith. As you progress with the language C, you will find that the string copy function will serve many purposes. One important reminder is that when referencing string data, use double quotes. When using character type data, use single quotes. Remember, single quotes allows a single character, double quotes allow multiple characters. That is the basic difference between character type data and string data in the language C. This program will demonstrate simple equations in the C language. I will take each equation, an addition operation, a subtraction operation, divide, and multiply, and demonstrate each one. The program as it now stands will accept two variables called sum A and sum B given initial values. The assignment statement will simply add sum A plus sum B and store the answer into the variable total. You'll notice that each of these variables are declared as short. Compiling the program will yield a clean compile, and then to run the program, as simply as you might expect, will display the total is 250, which of course is simply the addition of 100 plus 150. Now if I change this calculation to a subtract operation, using the minus symbol instead, now it will subtract sum A minus sum B. I'll need to recompile the program and then re-execute. And as you can see, the answer is stored as a negative 50. Again, it's subtracting 100 minus 150. Changing this to a multiplication symbol, which is the asterisk. Once again, I need to recompile and then re-execute. As you can see, it's produced the answer of 15,000. Once again, 150 times 100. And finally, I'll make this a divide statement, which is going to divide 100 by 150. After I clean compile, it then executes. You'll note that the answer in this case is 0. And that is because sum A is being divided by sum B, which yields a number such as 0.666. That number is a decimal fraction and is not a whole number. The variable total is being stored as a whole number, a short integer. So therefore any decimals are being truncated and the answer is being shown simply as 0. To solve this problem, we could change the data type of total from short to a data type of float. Now let's see what effect this will have. After I recompile, notice I get one warning at this point, and that warning says conversion from int to float possible, loss of data. And if I double click on this message, it is taking me to the assignment statement, which is performing the operation of dividing sum A by sum B. The problem here is that we have two integers being divided by each other, and they're being stored into a variable such as total, which is of type float. The compiler recognizes when you perform this operation, then it is very possible that you could lose data. In fact, if we perform this execution, you'll notice that the answer still yields to be 0. The proper way to handle the situation is as follows. When an equation contains mixed data types, that is, in our case, integers and floats, you should use typecasting to make each item of data that appears on the right-hand side of the equal sign the same data type as the variable that appears on the left side. To do so, we can perform a type conversion by placing the word float in parentheses immediately before sum A and sum B. When you typecast a variable, C++ creates a temporary copy of that variable using the new data type. Typecasting does not change either the data type or contents of the original variable. It simply changes it temporarily. We do not need to typecast total, since total is already declared to be of a type float. Let's recompile our program to see first if it eliminates the warning, which it has, and now we'll re-execute our program. As you can see, the answer yields 0.666667, which is the answer of our 100 divided by 150. This typecasting can be confusing, and we will spend more time on this later. I now have a complete program, which will demonstrate many of the features that we've discussed up to this point. The purpose of this program is to display a customer's name, amount of sale, and a total amount of sale. A simple calculation will need to take place to determine what is the total sale. Let's examine the parts of this program before compiling and executing. The first thing I'll draw your attention to is the compiler directive include iostream.h. This, you will recall, will allow us to use cout and cin type statements. Following this is the beginning of the main function, which includes our code. The first segment of the program is to declare and initialize variables. In this program, there are 4 variables. One is a string variable, which is called name, a short integer called quantity, and 2 floats, one for amount and one for total sale. As you can see, each have been initialized to 0, and in the case of the string variable, it is initialized to a blank space or a null string. The decoration of the name string will allow a person's name up to 14 characters to be entered. Remember, the 15th character is reserved for the null terminator character. Next, we have code to allow the user to enter data from the keyboard. This is accomplished by a series of cout and cin type statements. The cin.getLine will allow the user to enter a person's name, which will include a space, most likely between the first and last name. And then the next cout and cin statements will allow the user to enter amount of the sale And then the third set is to allow the user to enter a quantity. Next, we have a simple calculation that will multiply the amount of the sale times the quantity to calculate the total sale. And then the answer is being displayed in a cout statement, which is going to print the total sale, which has been calculated. Let's compile this program. And after a clean compile, we can now execute it. As you can see, the program is now running. I'll need to enter some data. I'll enter our friend John Smith once again. And the amount of sale I'll enter as $123.55. And we'll type in 3 as the quantity. As you can see, it has calculated a total of 370.65, which is the 123.55 times 3. So it appears this program is working. There is one item in this program that should be corrected, and that is the quantity is declared initially as a short variable. This should be typecast to float to prevent any miscalculation when you have a mixture of a float times a integer. Therefore, the typecasting will allow all data types, total sale, amount, and quantity, to be, at least for the point in time when this calculation is executed, that they are now to be type float. You may want to study this program in more detail. It is referred to as Demo 5 on your CD. Included on your CD is a demonstration program called Demo 6. It is a debugging practice program. As you will see when we run this, this program compiles normally, but does not produce correct results. Allow me first to give you some background on the code. The variables that are declared and initialized are mainly short variables. As you can see, they're all short integers, with the exception of the average worker hours variable, which is a float. Each of the integers have been given an initial value. In the case of the worker and hours variables, you can see the values given. The total workers and total hours and average worker hours have been initialized to 0. The next segment of the program is to calculate by adding the two worker figures together to get total workers, to add hours 1 plus hours 2 to accumulate total hours. The third calculation is to calculate the average, which is the total hours divided by the total workers. And then finally, we're using a cout statement to display the results of our calculation. Now, before I compile and run this program, you should note that the correct answer should be 8.83 as the average worker hours. Let's compile the program, which yields no errors and no warnings, and then produce the result. Now, as you can see, the average hours worked is calculated as 8. But as I have verified by hand, the answer should be 8.83. Returning to the program, do you see what the problem is? You may want to take a few minutes to look at this practice program to see if you can determine what the problem is with this code. Now that you've had a chance to examine the code, were you able to find the problem? Well, the problem is with the calculation of the average. We have a variable called average worker hours, which is a type float, which is being calculated as a division of two short integer variables, total hours and total workers. And as you can see, the results were incorrect. To correct this, we typecast by placing the word float in parentheses immediately before the variable that we want to change. Remember, this does not change the type of the data, it only does so temporarily. So now we have a calculation which involves a float equaling a float divided by another float. Now let's recompile our program to determine if this gives us the correct results. And as you can see, here's our answer, 8.83333. You should always verify your results with some test data to make sure that your calculations are indeed working. As this program proved, your program could very easily compile error-free and not produce correct results. It is up to you as the programmer to verify that your code is indeed working. Remember, rather than allowing the C compiler to perform implicit type conversion, which can lead to unexpected results in a program, it is better to use a typecast, which is referred to as explicit type conversion, to convert data from one data type to another. You typecast an item of data by preceding it with the name of the desired data type. When you typecast a variable, C creates a temporary copy of that variable using the new data type. Typecasting does not change either the data type or contents of the original variable. When an equation contains mixed data types, you should use typecast to make each item of data that appears on the right side of the equal sign the same data type as the variable that appears on the left side of the equal sign. This is a fact in C that can be cumbersome, so you need to practice with this and be aware of this at all times when performing calculations.